Hello everyone, welcome to CodeChef. Myself Jwala Chaurasia and today we are going to solve the problem which came into starters 199. The name of the problem is fence coloring and the problem code is FENCECOL. The difficulty rating of the problem is cakewalk and the prerequisite is head off. Let's start with reading the problem statement over here. So guys, problem says you have n fences and you want to color them. You have n total types of colors numbered 1 to n. Currently, all the n fences are colored with type 1 color. At the end, you want the ith fence to have a color of A05 for every I which lies from 1 to n. You can choose to do one of the following at each minute. Color all n fences at the same time with type X color, where you choose X which lies from 1 to n. Color a specific fence I with type X color, where you can choose X, where again X lies from 1 to n. Both of the above operation take only 1 minute to perform. What is the minimum number of minutes needed to color the entire fence as desired? Input format. The first line of input will contain a single integer t denoting the number of test cases. Each test case consists of multiple lines of input. If the first line of each test case contains n, the number of fences, the second line contains n integer a1, a2 till a of n. Output format for each test case, output on a new line, the minimum time needed to color all n fences. Constraint for t lies from 1 to 10 to the power 4, for n lies from 2 to 2 times of 10 to the power 5, for a of I lies from 1 to n, the sum of n overall test cases does not exceed 2 into 10 to the power 5. So guys, now let's understand the sample test case in the question more precisely over here. So guys, this question is pretty much straightforward. It says that you have n fences and you want to color them all, okay? So you have total types of color. So these are the total types of color, every color. So currently all the n fences are colored with type 1 color, okay? And at the end, you want the ith fence to have a color of A05 for every I which lies from 1 to 1. Okay, so we can do following thing every minute over here. That is either color all n fences at the same time with type X color, where you can choose X, where X lies from 1 to n, or color a specific fence I with type X color, where you can choose X, where X lies from 1 to n. So both of the above operation takes only 1 minute to perform. What is the minimum number of minutes needed to color the entire fence as desired? Okay, so now let's take the one of the test case. In the test case, we have got this 2 and 1, 2. Okay, so you can choose a color. You can choose to color the second fence with a color of 2. Thus, it only takes 1 minute. Since fence 1 was colored 1, right? So how many minute it took? 1. So output is simply 1. Okay. Now let's take one more test case. This is the second one. So we have got a 3 and these are 3, 3, 3. So in this you can choose to color all the fences 3 at the same time. Thus it only takes 1 minute. Yes, because the same. So output for the test case simply again 1. So guys, I think the test cases are pretty much clear. Now let's move towards the simple solution. So observe that if we ever perform a type 1 operation, that is an operation of the form color everything X with X, then all operation made before it are useless anyway, right? So this tells us that in an optimal solution, there will be either 0 or 1 operation of this form. And further, if there is one operation, it will be the very first one. Suppose there is no operation of type 1, then since we can only use type 2 operation, which affect a single index and every color is initially 1, the number of moves we need just equals the number of elements of A that are not equal to 1. Otherwise, suppose our first move is to color everything X, the number of type 2 operation needed is then the number of elements of A that are not equal to X. So if frequency of X denotes the number of times X appears in A, not performing a type 1 operation gives a cost of n minus frequency of 1. Performing a type 1 operation with X lies from 2 to n gives a cost of 1 plus n minus frequency of X. Computing the frequency array can be done in linear time, after which you can try all X and take the best answer among them. So guys, I think the solution is pretty much clear. Now let's move forward the simple C++ code. So guys, this is my simple C++ code. I took the input for all the test cases as well as my array. I made a frequency array and stored the frequency of every element. Okay. So over here, I initialize answer as n minus frequency of 1 and I'm running a for loop from 2 till n. And in this answer variable, I'm storing the minimum of answer comma 1 plus n minus frequency of I. And at the last, I'm printing my answer. And as you can see that guys, I have got my C++ code, right? Now let's move toward the Python code. So guys, this is my similar Python code. I took the input for all the test cases as well as my array. And over here, I'm making a frequency array. I'm storing all the frequency of every element. Okay. So I initialize this answer variable as n minus frequency of 1. I'm running a for loop from 2 till n plus 1. In this answer, I'm storing minimum of answer comma 1 plus n minus frequency of I. And at the last, I'm simply printing my answer. And as you can see that guys, I have got my Python code right. So, guys, I think the solution, the code, and the approach was pretty much clear. Now, let's meet in the next video. Thank you so much, guys, for watching our videos.